To calculate the standard service load for a duplex, we'll follow a step-by-step process. Firstly, convert the range load to 240 volts. Given a 7 kilowatt range, divide 7 kilowatts by 240 volts. This equals 29.2 amps, which we round up to 30 amps. Secondly, convert the air conditioning load to 120 volts. The air conditioner draws 21 amps at 240 volts. Multiply 21 amps by 240 volts and then divide by 120 volts. This gives us 42 amps, which is rounded up to 45 amps. Thirdly, sum the amperages of all appliances. This includes the 30 amps for the range, 5 amps for the garbage disposal, 11 amps for the dishwasher, 3 amps for the water heater, 15 amps for the heater, and 45 amps for the air conditioner. Adding these together, we get a total of 242 amps. Therefore, the standard service load is 242 amps. Now let's calculate the optional service load. Firstly, use the 35% demand factor for the range. Multiply the 7 kilowatt range by 0.35, resulting in 2.45 kilowatts. Secondly, calculate the amperage of the range at 240 volts. Divide 2.45 kilowatts by 240 volts. This equals 10.21 amps, which we round up to 11 amps. Thirdly, use the 50% demand factor for the air conditioner. Multiply the 21 amp air conditioner load by 0.50. This equals 10.5 amps, which we round up to 11 amps. Fourthly, sum the amperages of all appliances using the demand factors. This includes 11 amps for the range, 5 amps for the garbage disposal, 11 amps for the dishwasher, 3 amps for the water heater, 15 amps for the heater, and 11 amps for the air conditioner. Adding these together, we get a total of 109 amps. Therefore, the optional service load is 109 amps. In summary, the standard service load is 242 amps, and the optional service load is 109 amps. These calculations help determine the appropriate service size for the duplex, ensuring that the electrical system can safely handle the anticipated load. The standard calculation provides a more conservative estimate, while the optional calculation takes into account demand factors that can reduce the overall load. When performing electrical calculations, always refer to the latest edition of the National Electrical Code, or NEC, and consult with a qualified electrician to ensure compliance with local regulations and safe installation practices. Understanding the differences between standard and optional load calculations, and knowing when each is applicable, is a crucial aspect of electrical system design and can lead to more efficient and cost-effective installations. The optional method often results in lower service capacity requirements, potentially saving on equipment and installation costs. However, it's essential to apply these demand factors judiciously, considering the specific characteristics of the dwelling and the anticipated usage patterns of the occupant. Furthermore, remember that these calculations are only estimates. Actual loads may vary depending on factors such as occupant behavior, appliance efficiency, and weather conditions. Continuous monitoring and periodic reassessment of electrical loads can help identify potential issues and ensure the long-term safety and reliability of the electrical system. Also, keep in mind that local codes and regulations may have specific requirements or modifications to the NEC guidelines. Always check with the local authority having jurisdiction, or ODG, to confirm compliance with all applicable rules. This may include additional requirements for grounding, overcurrent protection, or other aspects of the electrical installation. A thorough understanding of the NEC and local codes is essential for anyone involved in electrical design or installation, and it's the best way to guarantee a safe and compliant electrical system. Proper calculations and adherence to regulations not only protect property and lives but also contribute to the overall reliability and efficiency of the electrical grid. By mastering these concepts, you'll be well equipped to handle a wide range of electrical projects, from residential wiring to commercial installations. The key is to approach each project with a systematic and methodical approach, carefully considering all relevant factors and seeking expert guidance when needed. Electrical work is a complex and potentially dangerous field, so it's always best to err on the side of caution and prioritize safety above all else. Finally, always remember to disconnect power before working on any electrical circuits, and to use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. With proper training, knowledge, and precautions, you can safely and effectively manage electrical systems and contribute to a safer and more reliable electrical infrastructure. To expand upon the calculation methodology, it's important to clarify the NEC guidelines regarding demand factors and the specific appliances included in the calculation. The NEC provides tables and articles that detail how to apply demand factors based on the number and type of appliances, as well as the square footage of the dwelling. For example, NEC Table 220.55 outlines the demand factors for household ranges and ovens, while NEC Article 220.82 provides guidance on optional calculation methods for dwelling units. When calculating the standard service load, it's necessary to include all connected loads at their full rated amperage. This means that appliances such as refrigerators, washing machines, and dryers must be included at their nameplate ratings without applying any demand factors. However, for the optional calculation method, demand factors can be applied to certain loads, such as ranges, air conditioners, and space heating equipment based on their expected usage patterns. The rationale behind demand factors is that not all appliances will be operating at their maximum load simultaneously. By applying these factors, the calculated service load can be reduced, potentially resulting in a smaller and more cost-effective service entrance. However, it's crucial to carefully consider the specific characteristics of the dwelling and the anticipated usage patterns of the occupants before applying demand factors. If there is any uncertainty about the actual load, it's always best to err on the side of caution and use the standard calculation method. In addition to the appliances already mentioned, it's important to include all other significant electrical loads in the calculation, such as lighting, small appliance circuits, and any dedicated circuits for equipment such as electric vehicle chargers or hot tubs. The NEC provides specific guidelines for calculating the load for these circuits, based on their intended use and the square footage of the dwelling. For example, NEC Article 220.12 requires a minimum lighting load of 3 volt-amps per square foot for general lighting in dwelling units, while NEC Article 220.14 specifies the load requirements for small appliance branch circuits and laundry circuits. When calculating the load for these circuits, it's important to consider the potential for future expansion and to include sufficient capacity to accommodate any anticipated additions or modifications to the electrical system. Overloading an electrical circuit can lead to overheating, insulation damage, and even fire, so it's always best to provide ample capacity to ensure safe and reliable operation. Furthermore, it's important to consider the voltage drop in the electrical conductors when sizing the service entrant. Voltage drop occurs when the voltage at the end of a conductor is lower than the voltage at the source due to the resistance of the conductor. Excessive voltage drop can cause appliances to operate inefficiently and can even damage sensitive electronic equipment. The NEC provides guidelines for calculating voltage drop in NEC Article 215.2. And it's important to select conductors that are large enough to minimize voltage drop to acceptable levels. The amount of voltage drop depends on the length of the conductor, the current flowing through it, and the resistance of the conductor. Larger conductors have lower resistance and therefore result in less voltage drop. When selecting conductors, it's important to consider not only the ampacity requirements but also the voltage drop requirements to ensure that the electrical system operates safely and efficiently. In addition to the NEC, there may be other applicable codes and standards that must be considered when designing and installing electrical systems. For example, the National Fire Protection Association, or NFPA, publishes a number of standards related to electrical safety, such as NFPA 70E, which covers electrical safety in the workplace. These standards provide guidance on topics such as arc flash hazards, personal protective equipment, and safe work practices. It's important to be familiar with these standards and to follow their recommendations when working on electrical systems. Furthermore, many states and local jurisdictions have their own electrical codes that may be more stringent than the NEC. These codes may include additional requirements for grounding, bonding, overcurrent protection, or other aspects of the electrical installation. It's important to check with the local authority having jurisdiction to determine which codes are applicable in your area. Compliance with all applicable codes and standards is essential for ensuring the safety and reliability of electrical systems. Failure to comply with these requirements can result in fines, penalties, and even legal liability. Therefore, it's always best to consult with a qualified electrician to ensure that your electrical system meets all applicable requirements. To further elaborate on the appliances mentioned in the calculation, let's discuss their specific characteristics and typical load requirements. The range, typically used for cooking, is a significant electrical load due to its high power consumption for heating elements. Ranges can be electric or gas, but the electrical load calculation primarily concerns electric ranges, as gas ranges have minimal electrical requirements. Electric ranges typically have multiple heating elements, each with its own wattage rating, and the total power consumption can range from 6 kilowatts to 12 kilowatts or more, depending on the size and features of the range. The garbage disposal, commonly found in kitchen sinks, is used to grind up food waste for disposal down the drain. Garbage disposals typically have a motor that drives a rotating impeller, which grinds the food waste into small particles. The power consumption of a garbage disposal can range from 1/3 horsepower to 1 horsepower or more, depending on the size and grinding capacity of the unit. The dishwasher is another common kitchen appliance used to wash dishes automatically. Dishwashers typically have heating elements to heat the water for washing and drying, as well as a motor to drive the spray arms and water pump. The power consumption of a dishwasher can range from 1.2 kilowatts to 1.8 kilowatts or more, depending on the size and features of the unit. The hot water heater is used to heat water for domestic use, such as bathing, washing dishes, and laundry. Hot water heaters can be electric or gas, but the electrical load calculation primarily concerns electric hot water heaters, as gas hot water heaters have minimal electrical requirements. Electric hot water heaters typically have heating elements immersed in the water tank, which heat the water to a desired temperature. The power consumption of an electric hot water heater can range from 2 kilowatts to 5 kilowatts or more, depending on the size of the tank and the wattage of the heating elements. The heater typically used for space heating can be a resistance heater, a heat pump, or a forced air furnace. Resistance heaters are the simplest type of electric heater, consisting of a heating element that converts electrical energy into heat. Heat pumps, on the other hand, use a refrigerant to transfer heat from one location to another, providing both heating and cooling capabilities. Forced air furnaces use a blower to circulate heated air throughout the dwelling. The power consumption of a heater can range from 1 kilowatt to 20 kilowatts or more, depending on the type of heater and the size of the dwelling. The air conditioner, used for cooling the dwelling, is a significant electrical load, especially during hot weather. Air conditioners use a refrigerant to transfer heat from inside the dwelling to the outside, providing cooling relief. Air conditioners can be window units, portable units, or central air conditioning systems. The power consumption of an air conditioner can range from 500 watts to 5 kilowatts or more, depending on the size and efficiency of the unit. By understanding the specific characteristics and typical load requirements of these appliances, you can more accurately calculate the electrical service load for a dwelling unit. Remember to consult the appliance nameplates for the actual wattage or amperage ratings, and to use the appropriate demand factors when performing optional load calculations. The NEC provides detailed guidelines for calculating the load for various types of appliances, and it's important to follow these guidelines to ensure a safe and compliant electrical installation.